Okay, have you ever thought of menstrual blood as, well, a discarded human starter pack? I know, it sounds a little shocking at first, but one scientist working on the absolute bleeding edge of biological engineering described it exactly like that. Quote, well, if you think about it, it's like the human starter pack that didn't get used. We're talking about harvesting stem cells to literally print human organs. It's absolutely mind-blowing stuff, and it perfectly sets the stage for just how radical physical prototyping has become in the modern world.
Welcome to The Explainer. Today we're going to look at a fascinating tale of two completely different innovation hubs. We'll explore how the very definition of physical prototyping shifts dramatically depending on the regulatory environment you happen to be standing in. We are going to compare a highly structured, traditional tech ecosystem with a frontier sandbox where the rules of what can and cannot be built are being completely rewritten.
Okay, let's dive into this. Here is our roadmap for today. First, the institutional innovation hub. Second, the bureaucratic bottleneck. Third, Prospera's radical make, DIY space. Fourth, cybernetics and 3D organs. And finally, the future of prototyping.
Section 1. The Institutional Innovation Hub, the corporate baseline of Chicago. To really appreciate the bleeding edge of science, we first need to establish our baseline, the traditional tech ecosystem. Take a look at 1871, located right inside the iconic Merchandise Mart in downtown Chicago. This is one of the world's premier nonprofit innovation hubs. It's explicitly designed to support founders from their very first idea all the way up to becoming a Fortune 50 company. It's sleek, it's highly organized, and it is backed by serious institutional weight.
Inside a hub like 1871, you find incredibly safe, predictable, and lucrative tech pipelines. They're leveraging massive corporate partnerships with heavy hitters. We're talking McKinsey, Discover, even the Chicago Cubs. The focus here is on scaling established, digestible tech models. They have an AI innovation lab, a food tech innovation lab, and programs dedicated to supply chain modernization. It's really all about optimizing the systems that already run our world, scaling them safely and predictably.
And when these founders need to build something they can actually hold in their hands, they head to something like the Fab Lab, a fabrication space designed entirely for prototyping physical products. This is where you go to iterate on hardware, maybe 3D print some plastic widgets, or design new supply chain tech. It is phenomenal infrastructure for sure, but it's fundamentally focused on traditional, commercially safe physical products.
Section 2. The bureaucratic bottleneck, when traditional hubs aren't enough. Because you have to ask yourself, what happens when the hardware you're trying to innovate on isn't a plastic widget, but actual human biology? For scientists working on the fringes of human capability, traditional hubs just don't work. As one innovator operating outside the US put it, bureaucratic regulations are extremely frustrating for scientists. Academic takes way too long. When you're trying to cure incurable diseases or upgrade the human body, the massive academic red tape of traditional environments becomes a huge bottleneck. The speed of innovation literally drops to a crawl.
This brings us to a really stark contrast between these two environments. On the left, we've got Chicago's Fortune 500 pipeline, corporate-backed, focused on safe scaling, using traditional fab labs. It's fantastic for what it does. But on the right, we have a completely different paradigm, Prospera's frontier sandbox. This is an environment defined by regulatory freedom, biohacking, and radical DIY creation. It's for founders who feel strangled by red tape and want to push the physical limits of humanity.
Section 3. Prospera's radical make, DIY space, innovation on the high seas of Honduras.
Before we get into the crazy tech, we really have to understand what makes this place legally possible. Prospera operates as a special economic zone, or SEZ. Essentially, it has its own distinct business and trade laws, completely separate from the host country's standard regulations. For biotech founders, this SEZ is a total game changer. It allows them to clear safety hurdles and begin commercialization without getting bogged down by the decades-long efficacy bottlenecks you'd find back in the US. It's a framework designed explicitly for speed.
And the physical heartbeat of this frontier is the Make DIY makerspace. If 1871's Fab Lab is where you build supply chain sensors, the Make DIY space is a community lab where founders work on rogue, radical biological innovation. It's an ecosystem that physically hosts the people trying to solve some of the world's most daunting medical challenges.
Section 4. Cybernetics and 3D organs, redefining the physical product.
Now, what's really interesting about this slide is just how sci-fi this reality actually is. Just take a look at some of the bleeding-edge projects happening right now at Make.DIY. You have founders walking around with 4 or more cybernetic implants in their own bodies.
You have researchers mapping simulated neurons, literally discussing the foundational steps of brain uploading. And perhaps most unbelievably, you have startups actively working to bio-3D print actual human organs.
Which brings us right back to the most ambitious, mind-bending project operating in this hub. A startup aiming to completely disrupt the global organ and tissue market. Their stated goal? We're aiming to be the world's largest stem cell supplier, utilizing non-invasive collection. And their source for these stem cells? Menstrual blood. Yep, the very thing we call the unused human starter pack at the start of this explainer.
Let's demystify this radical biology step by step, because the science here is absolutely fascinating. Step 1. They've developed technology for the non-invasive, at-home collection of menstrual blood. Step 2. They isolate the cells, utilizing the body's native antimicrobial and antifungal properties. Step 3. They take those isolated stem cells and differentiate them, basically reprogramming these blank slate cells to become specific tissues, like heart muscle. And finally, Step 4. They bio-3D print those tissues into organs. Because the cells come directly from the patient, it creates a perfect match cure, no terrifying risk of body rejection whatsoever.
But it's not just a medical miracle, it's a staggering economic disruption. To put this into perspective, right now, gathering enough stem cells to treat cardiovascular disease can cost a patient upwards of $100,000. This startup, operating in the high-speed regulatory environment of Prospera, believes their technology will drive that cost down to just $1,000. That is a 100-fold decrease in price.
And if you're wondering why this matters beyond just the impressive tech, well, there's a deeply human story here. The founder of this stem cell startup is driven by an incredibly personal mission. She has a spine injury that the traditional medical establishment considers completely incurable. Stem cell therapy is her only viable option for regeneration, but she couldn't afford the traditional $100,000 price tag. So she went to a special economic zone to build the cure herself, accelerating the research so she could test these therapies faster. It really gives this entire endeavor so much emotional weight.
Section 5. The future of prototyping. Where will you build?
And you know, this fast-tracked ecosystem is building toward even broader applications. It's not just stopping at curing injuries. It's actively attracting founders who are targeting the ultimate human bottleneck, aging. Innovators are flocking to these zones to repurpose existing therapies, aiming to, quite literally, slow down and reverse the aging process.
So, what does this all mean? As the cutting edge of innovation moves beyond software and hardware, we really have to rethink our environments. When the very definition of prototyping shifts from iterating plastic widgets in a safe corporate fab lab to 3D printing human organs in a frontier makerspace, where will you choose to build your future? Thanks so much for joining us on this explainer. Keep questioning the limits of what's possible, and we'll catch you next time.